Bienvenidos, Ushamdi, and welcome Anne Arundel Community College learners from the Spring 2023 semester taking the CTS-233 Section 400 Network Programmability course. This is the Cisco Networking Academy's DEVASC 200-901 Certification Exam Preparation course. And in this video tutorial on Lab 5.6.7, we're going to take a look at some network troubleshooting tools. And so here's what you're going to learn in this video. We're going to take a look at Ifconfig, the IP address command, ping, traceroute, and NSLOOKUP. Now, for those of you that are pretty network savvy, this might be review, so what I decided to do is I'm going to throw in some tips and tricks that you may or may not be aware of, and I would love to see in the comments below some other tips and tricks for these commands. If you've got some, drop them in the comments below. Would love to see that. Now, I'm going to be bouncing around a little bit here because of the way my firewall is configured. So we're going to be on an Ubuntu virtual machine. We're going to be out in a Kubernetes cluster. So we're going to be testing from all kinds of different locations here. So right out of the gate, let's jump onto my Ubuntu virtual machine that's running here on my iMac, which, if I was to destroy it, is no big deal in terms of all of the networking configuration. So here we are on that Ubuntu host. Again, let's check and see, do I have network connectivity out to the Google DNS server? And I do, so that's good news. So what we're going to do now is we're going to take a look at the ifconfig command. So ifconfig is an old school command, and you might be wondering, well, why are they talking about ifconfig and IP address? So no question, IP address is the new syntax. It gives you a little bit more information, but ifconfig is sort of an old school command. And so if I say ifconfig --help, we would see a list of the things that you can do with ifconfig. Now, you can do add an address, delete an address. I'm actually going to change the MAC address on this Ubuntu virtual machine on the interface adapter that we have on here. Now, you can also look at the man pages. So if I was to say man ifconfig, and this gives you a little bit better of a format in terms of presentation to read through. So you see if I do the ifconfig-s, we get sort of a netstat -i equivalent. If I do the ifconfig -a, you'll see that we see the two interfaces that are here. Now, take note that when you're using ifconfig, the -a option here is going to display all interfaces which are currently available even if they are down, right? So if I say ifconfig by itself and hit enter, this is what we see. But what if I say ifconfig, and actually I think I've got to do a sudo here because I'm taking the interface down. So if I say sudo ifconfig, and the machine's a little behind there. So if I say sudo ifconfig, and we're going to take the interface down, so I would say down, and let's do, or ifconfig, sorry, and we're going to do ENS33, down. All right, so you can see right here, it shows that the interface is up, but let's take the interface down. And then let's run the ifconfig command again. You can see ifconfig, when run by itself with no options, only shows me the interfaces that are up. To see all of the interfaces, even if they are down, it's ifconfig-a, right? And you can see I've already done some tweaking and testing here with the MAC address being changed, and you'll notice it no longer says up right here before broadcast. So how do we bring the interface back up? Sudo ifconfig ENS33 up. And then let's go ahead and say ifconfig-a, and you can see that now that interface is up. So can I ping out to Google? I can. If I take the interface down, what do you think is going to happen? So let's bring that interface down. Now what happens when I try to ping out to Google? Yeah, network is unreachable. So let's bring that interface back up. Let's confirm that it's back up. In fact, we can just say ifconfig if we wanted to only see the interfaces that are up. Right? Remember, the -a is going to be key. So we've seen how to bring an interface down. We've seen how to bring the interface up. We've seen how to look at the man pages for help. So let's take a look at another command. If you only wanted to get the address information for interfaces, right? I could say ifconfig, and let's do ENS33, and I can say grep on inet, right? And inet is what we're looking for right here, right? So it's only going to give me the addressing information for the specific interface. Instead of seeing everything, if I just want to pull the IP addressing information, I could run that command and pipe it to grep. So ifconfig, the name of the interface, pipe it to grep, and inet. All right, well, what if I want to change my MAC address, right? That layer 2 physical address that's burned in on the Ethernet adapter, right? Can you change this? You certainly can. So let's go ahead and do a sudo ifconfig, and we're going to say ENS33, and we're going to do, where's the 3s? All right, we're going to say ENS33 hardware Ethernet address, and I'm just going to do 99, 99, 99, 9. And again, this is theoretically this is hex. I could do, you know, AA, BB, whatever, 2, 3. And so we've got 6 groups of 2 characters each. I'm going to hit enter. And cannot assign request. Okay, well, maybe we've got, let's try AA there. All right, this should work unless I've got some kind of a typo in here. Because again, I changed it to, and let me take a look here at the history. I changed it to the 66s, so we'll say 66. Yeah, so unless I had a typo there, so 1349, and that worked. What if I try to change it to AA? There we go. Okay, well, it apparently didn't like me doing, maybe didn't like doing working it out with the 9. So we'll just change it to AA at the end. So how do we see that? Just ifconfig. If the interface is up, that's what we would see. And you can see right there that I changed the address. So theoretically, what we should be able to do here is AA:, oops, sorry. Come back here a second. :AA::AA::AA. All right, there we go. So now we'll say ifconfig. And you can see that the Ethernet hardware layer 2 MAC address has now been changed on this interface. So that's ifconfig. Now let's talk about IP address. Right now, remember, IP addr is sort of the new school way to get the IP addressing information. It's definitely the way you want to use. Again, ifconfig is still around on a lot of installations, and so it gets used quite a bit. And so now we can see sort of the similarities and differences between the presentations. So here, if I was to say IP addr, we get a list of the addresses, right? So if you're looking at the lab, they talk about the IP address command, and they actually run it on the DEVASC virtual machine, where it's going to end up showing you quite a few additional addresses, right? But it's going to give you the MTU, and these are some of the things that are highlighted. Shows you that the interface is up, right? I'm trying to mouse in there. There you go. Shows you that the interface is up, right? We see the Ethernet address as well that we had already changed. So again, it's just another way to see some of the addressing information. Now, if we were to do IP addr, let me click back in here. Sorry about that. IP addr show, that does the same thing. So IP addr and addr show is pretty much going to give you the same thing. But what if I wanted to get the interface IPs, right? I want to trim that down, so I could say IP addr and then grep on inet. And let's see what happens. And then here we get a list of just the IP address information that we're interested in. And again, you can see down here at the very end, it actually gives us the interface name, right? Loopback or ENS33. So we see that additional bit of information. If you wanted to change the address, and I'm not going to change the address here, but if you wanted to, we could say IP addr, or we could add an address to an interface. So I could say 192.168.1.122/24, and on which device? So I think it's ENS33, right? So that would add an address. If we wanted to delete an address, instead of add, you would just say delete, right? And so this is a way for you to kind of tinker with the interfaces on the system in terms of adding and deleting IP addresses. All right, so that's ifconfig, and that is also IP address, right? Remember, IP address is kind of the new school way to do things. So now let's pop out here, and we're going to go all the way over here, and we're going to take a look at the Kubernetes control node right here that's running out in AWS. It's an Ubuntu it's an Ubuntu EC2 instance. And so same thing, right? I can say ping --help. And you're going to get all of this information, right? It gives you kind of a shorthand list of all of the different options that you can run with ping. And so we're going to take a look at some of these options as part of the lab. And again, like I said, I'm going to try to throw some things in that maybe you didn't know. So when we do ping, right, especially on a Linux box, if I say ping 8.8.8.8, what we're expecting to see is that this is just going to run. And it's going to run forever on a Linux box. A DEVASC virtual machine is going to do the same thing for you. On a Windows box, you know that it only pings 4 times and then it stops. So on Windows, you would say ping -T. To stop it, you just do Control-C. So on a Windows box, I'm pretty sure it's ping -T, and I think that does like a continuous ping, like we just saw here that Linux does by default. So on Linux, if you wanted it to behave like Windows and only ping 4 times, I could say ping-C 4 8.8.8.8. And then what it'll do is it'll ping 4 times, and that's it, right? So you can, and the -C, think of it as is the count, right? How many times do you want to ping? So by default, packet size is 64 bytes, and you can actually send larger packet sizes. In fact, we can tweak and mess with the MTU by using the -S command if we wanted to change the size. And so for the MTU, not the actual size, but I can say ping-S, and we'll do 128, and we'll see what happens here. And sometimes it works, sometimes it doesn't work. So yeah, so it certainly doesn't like that, right? So it's not going to ping there. But again, the -S option, if we wanted to know what that was doing, I could say man ping, and here you go. You can ping -4 for IPv4 only, the audible ping. Let's get down to the S, lowercase s. There's an uppercase, a capital S as well. And so if we fly down here, yeah, packet size specifies the number of data bytes to be sent. The default is 56. The lab says 64 on this installation here. Oh, I'm sorry, which translates into 64 ICMP data bytes when combined with the 8 bytes of ICMP header data. Yeah, so it's 56 bytes, but it translates into 64 ICMP bytes. So this is great information right here. Again, the lab said 64, but in reality, 8 of those bytes are ICMP header data. And then you got the capital S, right? That's for some socket thing. But again, we can mess with the packet size that we want to send. Okay. All right, so not much to the ping command. Let's get the screen cleared here. Now let's take a look at NSLOOKUP, right? So we can run NSLOOKUP directly here, and NSLOOKUP is giving us a domain name to IP address resolution, right? So we're going to give it the fully qualified domain name, like a www.cisco.com. We're going to hit enter, and it's going to give us the canonical name. It's going to give us all kinds of information here about the different addresses that if I was to type in, or if I wanted to resolve cisco.com to an IP address, and you can see we also get the IPv6 information here. Now, you'll notice that it shows that that's the DNS server that I'm using, this 127.0.0.53, which is the Ubuntu host's sort of local name resolution. But what if you wanted to change the server or use NSLOOKUP interactively? So to do that, I just simply need to say NSLOOKUP and hit enter. And you can see here we got this little greater than sign, and that's putting me in the interactive mode. Now, if I type server, it's going to show me the server I'm using. What if I wanted to change the server? What if I want to use Google's DNS server? Well, you just simply type in server and the IP address of that server. And so now I'm using that server. So let's say www.cisco.com and hit enter. And again, you can see that that works. What about CNN.com? What about ESPN.com, right? And so we're seeing all of the DNS resolution information for these different domain names. Now, you could also do this, and instead of logging in here, the lab actually shows you to get out of here, it's Control-D or Control-C. I use Control-D. So you could say NSLOOKUP, and you could do this right straight away. I could say www.cisco.com and then supply the DNS server. And let's see, I think it's 8844 is the backup. Is that right? Let's see. Yep. And so you could actually supply the IP of the DNS server that you're desiring to use. and it's going to show you all kinds of different DNS information, excuse me, that might be available to you. All right, so there's also a debug flag, right? So here's like a little tip or trick. So you could say NSLOOKUP, and we could do -debug, and I could put the host name in here, www.cisco.com. And if we hit enter, you can see that we get a little additional information. So you can think of the debug, that -debug flag, as possibly being like a -v for verbose, or for making it verbose. And so that's maybe a little tip or trick that would help you out when you're looking up information. And you can see we're asking DNS questions and we're getting back DNS answers. And again, it went up a little bit higher up here as well, right? So you can see question, hey, Cisco.com, I got the address record. What do we got going on here? Give me all of the answers that you get back. And so then it gives you the answers. And it's actually kind of even a nicer format there, right? Excuse me. So we're able to see that. Now, the last and final utility that we're going to be taking a look at here is Traceroute. And Traceroute's got a lot going on. There's always a little bit of confusion around the output that you're seeing in Traceroute. So let's go ahead and break it down. Now, there's some, again, I mentioned I'm going to be out here on my Kubernetes control node, and the reason for that is the way that the DEVASC virtual machine is installed. Our VM is implementing a NAT network, right? So that it can communicate with our CSR 1000V. And that is more important than changing that DEVASC VM to bridged mode. Excuse me. And so they give us some limited output here, but they show us on a Windows box what we would do. And I'm going to show you probably some tips and tricks here that'll hopefully help you out. So right out of the gate, we could say man traceroute. And that's going to give you the man page for Traceroute. Obviously, if you wanted to see the version that you're using, you could say Traceroute. I think it was capital V. Maybe it was little v. We'll take a look here. And there you go. You can see we're using the Traceroute GNU iNet utils 194. So I could also say Traceroute and use the -- help. And that gives you kind of a consolidated version of things. It looks like you can even say Traceroute and -- question mark. That's one I have not seen before. Yeah, and it's just obviously gives you this right back. So for Windows users, right, you're going to type in traceRT, right, which just stands for Traceroute. Now, if you're a Windows user coming over to the Linux platform and you seem to be typing traceRT all of the time for Traceroute, you could create an alias. And so you would do that by saying traceRT, right? So I could say alias and the name of my alias and then the name of the command that I want my alias to run. So in other words, when I type traceRT, it's actually running Traceroute. And again, I'm saying traceRT to differentiate it from Traceroute, the Traceroute command on the Linux box. So I could say traceRT, and can we get to the Google DNS servers, 8.8.8.8? And let's see if that works, and it does. Now, the output that you just saw right here needs some explanation. You'll see that we're going to go for 64 max hops, right? So it's only going to check 64 hops. Each line represents one hop. And so the question that I always get asked is, well, wait a second. If that's the first hop, why is it showing me these 3 values over here? So take note that by default, Traceroute is going to send 3 packets, right? So, and that's what you're seeing here. You're seeing the results for the 3 packets. Now, the first one here, that you see the time, 12 milliseconds, 6 milliseconds, 25 milliseconds. And then to get to the next hop, right? It's 4 more milliseconds, 2.85 milliseconds, 3 milliseconds, right? So it's showing you the time in milliseconds for each of the hops. Now, what can you gather up from here, right, in terms of knowledge? Well, like, let's say that things are really slow for some reason, and you do a Traceroute, and you see right here that, let's say, for example, that the times here are like, 5,000 milliseconds or whatever the case may be, right? That may indicate, hey, there might be some congestion here at that hop. Now, the frustrating thing is, this is clearly, in this case, outside of my control, so there's not much I can do, right? But Traceroute is a great command to show you, hey, can I reach my destination? And again, we end up at the destination here. Now, 9 times out of 10, your output is not going to be all nicely packaged like this with everything working as planned. You might see some asterisks in there, right? So again, Traceroute's going to send 3 packets for each hop by default so that we can get some better granularity in terms of the performance. So what happens if it can't reach a hop for some reason? And I'm thinking that, let me try, and I'm not even sure that I'm going to be able to get it to break here. So let's try www.cisco.com. And yeah, no, so cisco.com worked perfectly. Let me jump onto my my iMac here, right? So this is a terminal window on my iMac Pro. Let me try to traceroute over to www.cisco.com. And the hope is that we might see there they are right now. Sometimes you'll see them right out of the gate, right? But other times you'll see them maybe in the middle of the trace that you're doing, right? And all this is indicating is that the packets are they've either timed out to that destination or they were dropped, right? So if I'm hitting a firewall, right, which is probably what's happening here coming off of my home network, and that firewall is blocking ping, ICMP requests outbound, right, then this is what you're going to get. It's not reachable. So sometimes in your path, you'll hit firewalls along the way. How do you stop this? Well, Control-C should get us out of here. And we'll see. Yeah, it looks like it might be. There we go. So Control-C will get me out of there. But that's what the asterisk represents. So instead of seeing, let's pop back over here real quick to the Ubuntu instance in Amazon's cloud. Instead of seeing the round trip time for each of the packets, you just get the asterisks, right? And so that's an alternative of what you might see. Again, Traceroute command is really, really good. A great go-to if you have some suspicion that, hey, I can't get to my destination, right? So you could try to ping to the destination, and then you can try to trace, and you can actually see, especially when it's in your own network, you can gain some really good insight into where are my packets going? What path are my packets taking to get out of the network? All right, and again, on Windows, it's Tracert, which stands for Traceroute. All right, well, that's going to do it. Hopefully you picked up some things here. And again, hey, leave a comment below if there were some tips or tricks that you have for any of these network utilities that help you troubleshoot your network. Love for you to share that information. All right, as always, thank you so much for watching, and I hope to see you in the next video.